Hello, you absolute legends. So this chemical reaction here, the combustion of butane out of this lighter, is releasing energy. And, I'm pretty confident it's releasing energy just based on how that feels there. In the lab that I asked you to do for this class, you watch a video of somebody producing the lab, and I'm going to kind of talk about that a little bit and try to walk through some of the questions there to go through. So in that lab right there, that guy has a can of water, and he heats it up. Now, no surprise that when you heat water, the temperature increases. And when that temperature increases, that means that the water must have absorbed energy. And we measure the unit energy in joules. There's a lot of there's other units you can hear to describe transfer of energy, like horsepower or newtons, but we're talking about joules right here. Now, in that video, he doesn't just use a lighter. What he does is he burns a piece of wood and a piece of charcoal. So this is my, let's see if I can do this. That's supposed to be a charcoal briquette, like out of a grill. Now that briquette is going to burn, combust, ignite, release heat on fire, and heat at the temperature of that water. Now, if we know the change in temperature of the water, we can calculate how much energy was absorbed by the water. And let's be very clear that whatever energy was absorbed must have been released from this briquette. So kind of hypothetically speaking here, let's go through a couple numbers. Now, what we can't make up and what's not hypothetical is what's called the specific heat of liquid water. The specific heat of liquid water is what tells us how much energy it takes to increase or decrease liquid water at 1 atmosphere. And that has the units joules per gram degree Kelvin. I haven't put the number in there yet because the units are what I want to build out of this scaffold. I want my final answer in joules, so I'm putting it up here in the numerator. Now, this has to be the grams of water, and this has to be the change in temperature of the water. And I need these units to cancel out, so that way all I have left is the joules of water, how much energy was absorbed with the burning of the briquette. So this is a known value that you just Google on Wikipedia, 4.184 joules per gram degrees Celsius. Now, I need to cancel out the grams here, so I need to know the mass of this water. In the video, he used a specific number that you should watch the video to work through the lab. I'm just going to make up a number of 100 grams just to keep the math simple. Now, because grams need to cancel, top cancels out bottom. Now, the change in temperature, in the video, he's going to observe a change in temperature and record it and give it out to you. I'm just going to, again, just make up a number just to keep things simple. I'm going to say that as this briquette was burning, the temperature went from 60 degrees Celsius to 80 degrees Celsius. So the temperature increased because the water absorbed the heat. So that is a change in temperature of 20 degrees Celsius. Note that 60 or 80 aren't in here. 20 is in here. So now that all my units are canceled out, top cancels out bottom, I just need to get my little calculator out. 184, 100 times 20. So I have a value of 8,368 joules of energy must have been released from this briquette. Now, this briquette, when it burned, now the next question involved in the lab is talking about the change in mass of this briquette. Now, when this briquette burns, it loses mass. As the energy is transferred, the masses of the carbon that's in here gets transferred into carbon dioxide, carbon monoxide, and those gases float off into the cosmos. Now, it's the same thing happens inside of a butane lighter. If you have a food scale at home, I recommend you buy a brand new lighter. Maybe record the weight and write it there on a piece of tape and cover it over, kind of protect on there, and then just use the lighter as you would, to do whatever you do with your lighter. And then whenever the lighter's dead, weigh it again on the scale. It has lost mass. We don't perceive it because it's so light and it's such a small change, but it loses mass because that mass in there, that chemicals are being converted to release energy. So I'm just going to make up some numbers for this change in mass of the briquette. Let's say that it started out at 20 grams. That was the initial. And then after the burning, it was 18 grams. That's how much it weighed. So it must have lost 2 grams. So its change in mass was 2 grams. So that briquette lost 2 grams of stuff in the burning to release this many joules of energy. Now, the next question in the lab talks about the energy density of this briquette. What is the energy density? So we want the energy density in joules per gram. And if that's the unit we want our answer in, we just fill in our scaffold to match those units. 8,368 divided by 2, because that's the joules of energy released. That's how much mass was lost to release that much energy. 4,000, I think I can do this in my head, 4,184 joules per gram. That's just a coincidence because I just use easy numbers here, 100, 200. But 4,184 joules per gram is the energy density of that charcoal briquette just based on these made up numbers I have right here. I hope this helps. Thank you.